Did you find that on? Is that on the? That's the most recent version from the web. Yeah, that's okay. I think it is also the yeah. Yes. What's the So, good afternoon. MPLS is about to start. We will have two sessions. One is today, the other one is on Friday morning, and there will be also a joint session with C-Camp on Thursday. So note well, it's a new note well. Yeah, I think. Please.
So Lou put it in the Teams meeting as if you, for example, hum on one particular draft and you know about an IPR on that draft, you have to disclose. So everything you do, say, or go about here is under the note well. Please take care and disclose if you need.
And read it carefully, yeah. So a couple of administrative, so please speak to the mics. There should be pink squares on the floor, in fact, but I haven't seen one. Oh, here's one. Okay, so please stand inside the pink square. All material is uploaded to the MPLS working group page. We have 2 minute takers, I guess. Yeah. Meet Echo is active, and as I said, agenda and so on the web.
So we have had a couple of smaller problems. George couldn't travel, so he won't be here this meeting. Tarek was about to go to the airport in Toronto, I think, and it was raining, so the flight was cancelled. He should be arriving about this time, but we haven't seen him yet. So if there is anything in type of misspelling on agenda or slide titles or things on the uploaded agenda, it's probably I that's been there. It's not Tarek. Okay, so we have agenda for today. I don't think it's too much idea to bash the Friday agenda because we will do that on Friday morning, or actually I should say that first before I start. What we have done is actually we swapped the MPLS slot on Friday to 10:30, borrowing time from routing working group. We haven't. You have agreed, so. So we will start the MPLS meeting on Friday at 10:30 and hopefully end 11:30. We were doing this because we were in the same room, so it was just swapping us up in time. And some of us had something we needed to do where we could do during the MPLS slot in the afternoon. So it was very peaceful. Okay. Anyone that don't want to bash the agenda? One thing, we have a longer slot, 30 minutes. That's slot number 8. We're going to discuss BFD directed, the draft that has been stuck for a very long time. We want to see if we can come to a situation where we can move it ahead. BFD share at the mic.
Jeff Oz, so my request is to maybe bump the BFD topic a little bit further up on the offhand chance that other topics want to push it out. I will not be here on Friday to participate.
I couldn't hear you. You close your mic and loud.
Could you please move the BFD presentation today further up the schedule so that it doesn't get pushed out into Friday? I will not be here on Friday.
No, it's not on Friday. It's today.
I am aware what the schedule says. I'm also aware that topics overrun.
Ah, okay. Let's see if we have. We actually have a 10 minutes buffer at the end. It should work.
You are optimistic.
So let's do it like that. We put it as slot number 4. That's fine. Okay. Is everyone okay with that? Mac, you just got pushed down. Is that fine? Okay, great. So we had a slot 3B that we do the BFE directed. And let me see, we have Carlos in the room, we have Greg in the room, and we have Lou in the room. So we have everyone here. Good. Anything else? Okay, we go with this agenda. Let me see, where are we? So, blue sheets has been started, pass them along, and when you assign them as the last one on the last row, forward them to the chair, but check if there is anyone that has not signed yet.
No, there are only 2, one there and one there.
Okay, so when you're done, it's actually coming down in the middle, coming this way. Okay. Let's see, this one is dead. We have an Errata that actually been approved, and it was kind of, the way I'm reading it is just a grammar change, and I don't have any opinion on English grammar. But other than that, it's hard. So it's approved, and it should be kept for update. We have incoming liaisons. I think everything here is under control, and we will kind of work on a response with the other working groups. And we haven't sent any liaison. However, we are preparing a liaison at the moment that will go out as soon as we can get it sent. And it's just telling Study Group 15 that the Mpls TP shared ring protection has been approved. Okay. We have new RLCs. I think it's 3 of them. That's kind of normal between 2 meetings. Next slide. We have 1 new working group document and a lot of working group documents that has been updated. The blue documents in this list, these lists are documents that will be on the agenda. We have discussed the temporal hitless PSM document today. I have discussed it with Deborah, and we will try it one last time and see if we can get it moving. Okay. There are a number of new IDs, and like half of them are on the agenda later today or on Friday. So the list here is not that I'm going to talk about each and every draft. If you have questions on draft, you can ask them. Otherwise, this is just a bookkeeping, so we can go back and check what was up at the meeting in Prague 2017. We also have a number of documents that might be of interest for people here that are in other working groups. We list them for the same reason, just as a heads up, and you can check if there is anything you need to pay attention to. That one is, yeah. Okay. So I'm aware of updates not updates really, it's information on 2 drafts. One is the opportunistic security draft. That one, if I understand it correctly, will be allowed to expire unless Stephen can find a student to do some student work, then it will be revived again. We also have the 5036 BIS, still an individual draft. The next thing we will do in that draft is actually to rewrite the IANA section. I talked to IANA last time and I got an instruction on what to do, and I tried to do it and it came out very awkward. So I talked to them again and then it will be updated. Stuart?
Could you just clarify what the issue with opportunistic encryption is?
The issue is that we didn't have any taker to do. The plan was to actually get students to do a student project around it and then forward it as an experimental draft, experimental RLC. We couldn't find the student. Actually, we found the student, but the student defected. So if Stephen actually can find the student, we will revive it again. There's no technical issue. Okay. So Yahoo, you changed.
Yeah, I push this one or?
You see it there.
You see it here.
Good afternoon. My name is Shao Wen from Juniper. On behalf of all the co-authors here, today we present this unified source routing use Mpls label stack here. So basically, since version 0, 3 author, Gunter from Nokia, Jeff individual, and Shao Wen added into the co-author group here. And then we are also modifying something on the adjacency seed, and also some text to indicate the benefit of using second routing, even the full upgraded Mpls Spring domain. This method will also working here. So the first topic we will talk about is the traffic engineer as the overlay part. So the traffic engineer or the transportation previously was thinking as an underlay or transportation somehow. But the traffic engineer is actually a capability along those packet size somehow. So with any transportation, if you try to adding the traffic engineer capability as one of the overlay capabilities, such as one optimization, another somehow. So that's why we try to highlight with the second routing label here, with the label stack, you actually can adding any existing transportation, the similar traffic engineer capability on this one. So especially certain successful deployment, such as Google before and others. So they really thinking traffic engineer is not a transportation or just the underlays, pretty much the add-on function on top of that. So I think this one is not the latest one actually. And we changed the picture.
Okay, but that's one.
Version 2. This one is version 0 slice. Sorry. Yeah, this one. Yeah, this is. Go down. Oh, still. Okay, anyway. I really changed a lot of picture here, so it's gone. But anyway, so the idea here is we use traffic linear as an overlay here. Then TE pass is actually just a set of label stack. Then the transportation will be the IP GRE or IP UDP header across different node and so on. So in that case, the first use a second routing label stack, not for transportation, just for traffic linear capability here. So if you try to send the packet from one end to another, then you really want traffic linear in the middle here. You can actually use GRE, UDP, or even L2TP, any tunnel mechanical. The certain node in the topology here is upgraded to support those functions. So the key function here is when you first hop router receive the packet, they will find out the next capable of this router. So the routing protocol update maybe just leverage the existing second routing V6, second routing SS or OSPF. Then the node A and node E and G, and somehow they actually exchange the information, exchange the label stack information for second routing. Then between the A and E, a certain node in the middle, they cannot support either Mpls second routing, or you cannot support totally understand this capability. Then you actually sending in-cap into a UDP or GRE header from A to E. Then the next one, you actually can push a label stack to stand for the traffic linear capability here. So then the next node, E, you actually not looking for, you actually decap the GRE header or the UDP header. Then you look at the first label stack here. So this label is not swapped to another label. This outer label, so the label G is actually look at in node E, then mapping to the UDP header. So the lookup engine is you have a label, incoming label. Then this label, you outgoing is a GRE tunnel or the UDP tunnel. Then find to the node G. Then you go to the node H and so on. So that's a procedure here. So the key difference between this draft and the second routing normal second draft is the forwarding behavior change. So previously the second routing, you actually pop up a label, then you actually swap or follow another label. But this time, use this label, you look up for the next adjacency, which is a tunnel somehow. So that's actually can working for both IPv4 and IPv6. And even certain node in between, they only support IPv6 forwarding, no capability for Mpls and so on. So those boxes, if you upgrade to this capability, then they can forwarding as well for IPv6 as well. So can you put to next one? Previously one. Yeah. So another capability for this one. So we're adding this label stack for traffic linear capability. Then we keep the VPN capability as another label here. So this method will working with any existing VPN mechanical, layer 2, layer 3, EVPN, and so on. So all the existing protocol will be support here. So in that case, if you look at the label stack here, the innermost label VPN instruction, then you can differentiate different label VPN domain here. Then the right tunnel is just transportation. Then in the middle is TE pass or the second routing traffic linear capability add on to that tunnel as well. So you follow the similar function. Then the last hop for the hop H, you actually look at the VPN label, then you forward to the different VPN instance here. So certain advantage over second routing V6 here we saw. is actually we have a 4-byte MPS label encapsulation, other than the second routing V6 is 16-byte. Then we also backward compatible with all the MPS spring here. Then seamless integration with existing MPS VPN, and better load balance because of UDP source port. You can use load balancer from a first hop router point of view, but if you encap the GRE tunnel from a host, then you lost those capability as well. So another advantage here is all the existing hardware, including the latest Broadcom chip, like Trident 3, Jericho can support MPS over GRE, MPS over UDP. All the major vendors box can support this one without any hardware change. So that's kind of the advantage here. Then we also not try to replace MPS Spring here. So it's basically the incremental deployment with MPS Spring. So for certain customer, they really think 5G IPv6 will be the future. Then get rid of the MPS transportation. Then use IPv6 as transportation, adding the TE function on top of that. That's the benefit for this one. So basically, the solution overcome the load balance problem by this. There's actually two problem with second routing with existing hardware somehow. Basically, certain ASIC can only read certain depths of label for load balance in between. Then another one is the ingress router, how many label you can push. That's another problem here. So you either way, we know we have a certain alternative solution, but this is a true problem for the existing hardware on implementation with second routing. But with this new method, you have a better choice here. So let's come to the next step. So any comments on suggestion? Anything? So I'm so sorry, the slides are kind of a mess up. We do have a better version. That's why. Okay.
Bruno de Crane, Orange. Two comments. First one, I'm not sure to see what the standard track document is trying to specify. If you remove the use case on the figures, it's a one-page document that you can summarize in one sentence, which is, if I am an MPLS node and I don't have MPLS connectivity to my destination or FEC, I can use an IP tunnel. And that point is already specified in the MPLS in UDP RLC. So what is the new specification?
So the new capabilities use transportation tunnel together with the TE stack for the traffic linear. Previously, if you only do the tunnel part, you cannot have the per hop forwarding behavior, then which is very simple. Use label to tunnel mapping from the hardware point of view.
I believe with the MPLS in UDP draft, you can put any MPLS packet, including a stack of label. So.
My name is Xiaohu. One course this draft. The purpose of this draft is to describe how to leverage the existing MPS capability, including MPS and routing and MPS over UDP tunneling technologies, to realize TE overlays over IP transport or IP overlays, IP underlays. That's why this draft is informational.
No, it's standard
draft.
track. It's standard track.
What?
It is a standard track draft.
Oh, okay. Why its draft was changed from informational to standard track is we want to reduce the MPS source port label triple field. In that way, there's no need to insert triple labels within the MPS label stack. In that case, when transit SR router decapsulate UDP tunnel, it should remember the source port value. That is the triple value. And then when it's perform another encapsulation, it can reduce the cache achievable value. That's difference from the existing Mpls forwarding forwarding capability. So that's why this draft is.
It's different from MPLS to MPLS, but it's not different from MPLS to UDP tunnel, MPLS in UDP tunnel, which is already specified.
The encapsulation is no change. But the difference is we want to reduce the source port label as only achievable field for the MPLS over UDP packet. That means there's no need to insert any achievable labels within the label stack.
Okay, I think we can continue on the list, but
Okay.
I'm not seeing the specified part in the draft.
Okay.
Second question, what is the relationship with draft variant, which is called a unified approach to IP segment routing? I see a lot of overlap between two drafts in terms of technical content, in terms of authors. So do we need two documents, or they're going to be merged? Or?
Well, we're still talking about it, but the issue will be resolved.
Okay, thank you. You mean they're going to be merged, or?
We're still talking about it. Let's work
Okay. But you target one draft.
There's clearly only one technology.
Yeah. Okay.
But we may need architectures as well. We're not sure how many drafts it would take.
Stuart,
to properly,
closer to the mic.
we're not sure how many drafts it would take to properly describe this, because it's part of a bigger problem, as you will note, with the next draft that's going to be discussed. We need to work through this. There's still individual drafts. We still need to work through the process.
Okay.
So we need to keep it short now. We're running out of time. Quick question, quick responses.
Yes. So that's all for my comment at Orange. Now with Spring Co-Chair, exactly all your slides are about Spring or segment routing. So why do you think the MPLS working group is a good home for that draft? Because it's all about Spring. So you will probably have better feedback in Spring.
I can take that. When something comes in as a new draft and it has some relation to more than one group, we start presenting it in one group, and then we socialize it with the working group chairs that we think would be interesting. In this case, I think you should be one of them. I think Lou and T's group could be one of them, and we decide which group actually takes this.
Okay, but from the draft, from the slides, it's all about Spring and
Yeah,
segment
basically
routing.
it's a segment routing inside this tunnel mechanical, and we try to overall see the value in the existing topology and network and so on.
So if you want feedback, I think you will have a better feedback in Spring.
Okay, let's talk about it offline.
Ahmed Bashandi, Cisco Systems. Can you go back 2 slides? One more. I just want the one that has nice diagrams, colorful ones. Yes, this one. If I have a IP and IP tunnel between A and E, and I treat it as a virtual interface, this is exactly what you have here, right?
Yep.
So I'm asking the same question. What is new here? It's just you're running segment routing over a virtual interface, which is an IP tunnel. That's it, right?
So Xiaofu may take this question, but
In this approach, there's no need to configure any explicit tunnel between A and E. When A want to set MPLS packet, the top label indicate E, but there's no outgoing label for E. So A will pop the top label, then encapsulate MPLS packet within UDP tunnel.
Okay.
so and also let me comment.
I think I have to do what chairs often do in this organization. Take it to the list, please,
Okay.
and
Okay.
actually take it to the list, because the discussion needs to continue.
Okay. Thank you very much.
Dmitry Afanasyev, Yandex. Just a short comment on pushing large label stacks. At least in controlled environments, now we can extend MPLS forwarding all the way to the edge. Modern top-of-the-rack chipsets are perfectly capable of forwarding MPLS, and that means, at least in some cases, we can push label stack on the host.
Yeah.
And in fact, there are good arguments why pushing long and complex label stack on the host is a good idea, at least in some cases.
For sure. So pushing a longer label stack is not a problem. But in the middle, the chipset capability, how many labels you can read, then make the decision for the load balance. That's a problem. Yeah.
Yeah.
Okay, thanks. We have to go on. Thank you very much.
Thank you.
See you on next.
Good afternoon. Let's talk about how to leverage unified source routing mechanism to realize service chain. Changes since the last IETF meeting, 3 co-authors ended, and some tests about how to carry metadata within MPS packet is ended as well. As you can see from this picture, the service chain is realized as overlay, just as what had been mentioned by Shawan in the previous presentation. The MPS stack, which is used to indicate a service chain or service function path, is encoded as MPS label stack. That label stack is then encapsulated over UDP tunnels. So with this approach, it fully meets the transport impedancy requirement for the server chain, which is listed in the server chain architecture requirement RFC. Since there are no explicit protocol ID field within MPS packet, so it will be hard to indicate whether metadata is contained or not within MPS packet. There are multiple solutions to address this issue. One is to allow the service function forwarder to allocate 2 labels. One indicates the presence of the metadata, another is to indicate the absence of metadata. Here, the metadata is contained in, the metadata could be contained in network service handler. That means the network service handler play a role of a metadata container only in this case. Of course, more details need to be specified in future versions. Advantages over NSH. First, land states on service function forwarders. The same with claimed benefit of SRv6 based service chain approach. Second, it's leverage the efficient MPS network programming capabilities. Third, it's built on the existing MPS hardware forwarding capabilities. Comments, suggestions?
Any questions?
Thank you.
Okay, thank you. So we are at the BFD directed slot. We're going to start with Lou, talk about IPR and things related to that, Note well and other things. Then we're going to make Carlos go over his review, and then Greg finishing up. And there should be time for discussion.
Hi, I'm Lou Berger. I was asked by the chairs to talk a little bit about IPR. Not sure exactly where the group or the chairs want to take this, so I'm just going to give you some high-level background if you and then open the floor to questions. Hopefully it'll only take about a couple of minutes. This is the note well, the new note well. It's basically the same as the one we've used for the last couple of years. The biggest difference is that we now highlight that RFC 8179 is available. 8179 provides an update to the IETF's IPR rules, excuse me, disclosure rules. And notably, it clarifies what is a contribution and what is not a contribution. Basically, it says that anything you do on any of in the public arena of the IETF is an IPR contribution. That's whether you do it electronically on a list, whether you do it within a design team, whether you do it in person here by saying something, or if you participate in any way in a working group activity. And a working group activity, and it goes into this, is certainly giving a presentation like this, although obviously I don't have any IPR on it, talking at the mic, raising your hand, humming as part of a poll, or even expressing some personal opinion through whatever means, like frowning when someone is presenting an idea. That's even considered a contribution. Basically, the rules also say that if you contribute to the IETF or contribute to work in an IETF, that you're subject to the disclosure rules. And I think I have this on the next slide. The disclosure rules basically say, if you participate in any way, you contribute, you're required to disclose any knowledge you have about IPR on the topic. Sometimes it may happen that you contribute and then find out about IPR, then you need to disclose it at the most, I don't want to say convenient, but timely fashion as you can. If you know about IPR and you want to contribute, but for some reason you can't disclose that IPR, the rules say you can't, basically they say you can't contribute. So if you know of IPR and you're not willing to disclose it, don't participate. I had this happen to me personally. I just never walked in the room of that working group, ever. Didn't even subscribe to the list. There are lots of ways you can handle it individually. You should take a look at the new rules and decide how you want to deal with them. Clearly, some conversations that happen while you're at the IETF are not subject to IPR disclosure. And the document 8179 clarifies if you're having a private conversation, even if it's in the building, but it's just a one-on-one thing, and maybe it's vendor to customer, or maybe it's to a colleague and you're talking about some design, that's not subject to IPR. So it's not like the rules are trying to be crazy here. They are trying to be reasonable. So what do you do if someone doesn't disclose? First of all, from a working group standpoint, it's the working group chair's responsibility to deal with that situation. Anyone who's participating in the working group, anyone who's participating in the IETF is welcome to help identify that situation is going on. But really, it's the chair of the working group to figure out how to deal with it when it's in the context of a working group. The ADs play a role, particularly as you get to the sort of more severe responses. You definitely have to involve the AD, and the AD can certainly be the person who's alerted to about the IPR. There is a way to do third-party IPR disclosures, and that's also covered in 8179. There's an RFC from Adrian, who's not in the room. I think he's chairing a different session. That talks about what are the sanctions available to the violations of the policy. The sanctions are actually, I wouldn't call them all that heavy. They're related to our process. And the draft lists 10 items, ranging from if a chair hears about an IPR, or even an individual can do this, you go talk to the person and say, hey, you know, there's this IPR right here. Please disclose it as quickly as you can. And sometimes they'll say, yeah, I know, I should have gotten it done. We just didn't. Or it's working its way through legal. That happens. We deal with it. If the lack of disclosure becomes a repeated offense, or it's pretty egregious, you know, the person who's the lead author of the document is also the lead author on the disclosure. I'm sorry, on the patent filing, and the patent filing was 5 years earlier. You know, clearly the person should have known. That's pretty blatant. You might start looking at some more, some of the more extreme responses, and basically the chairs can end up removing someone as an author, moving them down to the acknowledgement section, or even if it's really a repeated thing, you can just stop them from participating in the working group. And to do that, by the way, you have to involve the AD. I think I've covered this at a high level. I may have missed something. I'm sure I did, but if you have questions, please.
So, Louis.
And by the way, I'm just speaking as an IETF participant and someone who's been a chair and had to deal with these issues over the years. I happen to also be on the IOC, which makes me a trustee. I am not speaking as a trustee in this forum.
Okay. Greg Merskiziti. I experienced that many times with the early disclosure before their application being published. It creates some confusion because no one can really evaluate the relevance of their IPR to the draft.
If you notice, there's no statement here about evaluation of relevance. So once an IPR is disclosed, it's up to the working group members to decide how they want to do, what they want to do with it. The IETF, no IAB member, ISG member, working group chair is going to evaluate the statement and say whether it is a reasonable claim. As a working group chair, I've had documents which are sort of like problem statement, and someone does an IPR disclosure about them. I won't say whether that's reasonable or not. I say, what text does that apply to? And they say these paragraphs. I said, okay, those paragraphs are removed from the document.
Right.
So I've certainly done that as a chair. I've also seen working groups that when an IPR disclosure comes in, look at it and say, you know what, we don't want to work on that direction of that technology. In an extreme case, and it's talked about in the draft, is you can, and it's even mentioned on the slide intentionally, the working group can say, fine, we're not going to work on that technology at all. You know, maybe that's not our main business. This is something we want, but because of that disclosure, we're not going to do anything in that area. That's a reasonable option or an available option to a working group. But it's up to the working group to decide. And basically, we have information, and then we follow our consensus process.
Right, but again, for somebody in the working group who wants to do the research himself, the existence of the published application is important.
Sure, it's very convenient. You're right, absolutely. But it's not a requirement. It's not, you don't have to wait for the information to be published, the patent application to be published in order to make an IPR declaration. In fact, as I personally interpret the rules, you shouldn't. So if me as a individual go write a patent application and then go write a draft that patent application relates to, I believe I have to disclose at the time I publish the internet draft. That's the way I read it. I'm talking just as an individual, but that's how I read the draft.
I agree that that's the policy.
And by the way, this is the exact thing that I was referring to for me personally. I had a patent application in an area, something came up, things weren't public. I didn't want to file, I didn't want to talk, I didn't want to disclose it because things were still working its way through. So I just didn't touch that area whatsoever.
Okay, no, I agree, because the thing is that personally, that's the policy I follow and try to encourage the holder of IPR to do the right thing.
Yep.
So whilst this is an interesting area, and actually my view is that the process is fundamentally broken because you can't have a detailed discussion in the working group about the details of the IPR, I'm curious, why are we having this discussion here? Have MPLS working group been particularly bad? Because this seems to be a discussion we should have in the area meeting tomorrow rather than in a technical meeting.
Stuart, I can take a partly response to that. I have a situation where I need to deal with the document we will discuss and an IPR disclosure against that document. And I want to know what I can do, what I can expect the different parties to do, and what I can do if they don't do what they don't do what they should do.
Oh, so we have a live problem that is affected here.
I think we had the problem, and I wish that people would just sit down and say, okay, it's gone away. The situation is like this. We had a draft through working group last call. We got an IPR, a blocking IPR comment on that. Both of those persons that actually made that comment at that time has now said that, okay, that they have withdrawn their blocking comment. So I'm happy with that. Now, that is partly because the draft was changed, but the IPR holder has not done anything, and I don't think we can actually require the IPR holder to do anything. So it's up to us to evaluate and go ahead from that point.
You're correct. There is nothing that the IETF can do to compel an IPR holder to disclose, to update a disclosure, to remove a disclosure. There are certain recommendations in 8179, but there's nothing that will compel them. It does also mention that failure to disclose IPR and then bringing work into a standards body and knowingly not disclosing that IPR in certain venues has resulted in the patent claims being invalidated. That's what it says in the text, and it notes that. So there's some good incentives out there for IPR holders who want to enforce their IPR to disclose. But those incentives aren't imposed by the IETF. They're coming from the existing legal framework.
We actually have a quite different situation here. We don't have a failure to disclose. We probably have a over disclosure.
So you as a chair can't correct that. All you can do is, as a working group, look at it and decide whether or not you want to continue with the document, continue with the technology, change the document, change the technology, and whether you want to submit for publication request. That's all you can do.
I think we all know.
I mean, it would be nice to do more, but...
Carlos Pignataro, Cisco. Lou, I have not read 8179. I have read previous versions, A to C, every letter. I still do have a question, which is...
By the way, I'm not an author of 8179, so I'm right in the same boat as you. It's just
Oh, you read it. I didn't. So you're better positioned to answer this than me, for sure. There's a draft, right? Hypothetical situation, an IPR gets disclosed against it. The working group works around the IPR, right? Changes the document, moves on a different way, remove the paragraph that you alluded in your personal example.
Yeah.
What are the requirements to the IPR holder or to the person doing the disclosure if they know the IPR doesn't apply anymore, if any? Like, are there requirements, or can that be forever ad infinitum in there?
So there are no requirements on IPR holders in this process whatsoever. Full stop.
To disclose C.
All right. And there are obligations to a disclosee, but it doesn't include that they must remove IPR that they believe has been removed. It does not include that. Whether that's an oversight or not, that's a good thing to bring up in Singapore, because the authors of 8179, notably George, who's the paid attorney for the IETF, he's going to be talking, they're putting together a presentation and they'll be talking through this. So that'll be a good place to ask why that's not there or should it be there. I can tell you it is not there. There is no obligation to say remove. In that personal example that I referred to, that draft still has that IPR. Yeah, it's a still draft. The draft still has an IPR reference against it, even though we know the text's been removed. The reality is, well, if it ever goes to court, we'll deal with it then.
Stuart, Brian, I was going to basically reinforce your very last point, which is that no one knows the validity of the IPR or the applicability to the changed text until a judge has looked at it and decided in court. And that's way beyond our capability.
That's right. All we can do as a working group is decide whether or not to progress a document. Simple as that.
And actually, the licensing condition actually comes in. If it's a free for use, then
that may be a discussion in the working group. There is no position that I know of within the IETF management structure or process structure that says that.
But wait a moment, we're explicitly excluded from discussing licensing terms. So that's a piece of the broken process that I pointed out to Scott several times. Because we can't discuss those, we can't actually have the conversation you want.
I'm not sure that's completely correct. For example, the document 8179 talks about that there are certain areas where the IETF has expressed an interest in certain IPR licensing terms. For example, in cryptography, and that's the example it uses in the document, there's an expressed bias by the IETF to do things that are, I don't remember what the right term is, but there's some license that they prefer. So, you know, for example, if the ISG did come up and say, we prefer this, that would be okay. The document does go into a little bit of an explanation of why the IETF currently doesn't do that. Okay. But you're right, as a working group, you know, you can look at a document and say, I don't like this disclosure. Because of this disclosure, I don't want to support this document.
Right, but you can't say I don't like it because I've got to pay money, or I've got to pay this much money, or negotiate the amount, or anything like that. It's a whole load of stuff that we're absolutely forbidden from talking about due to antitrust.
If we're getting into what we're allowed to talk about and not allowed to talk about, I think at that point we need George to come talk to the group, because I'm not a person who should.
And I'm just reflecting what George said to me on a different occasion.
Okay. Can I go now?
Thank you.
Thank you.
So, Carlos. So what I think I have at the starting point here is actually that both Carlos and Carlos has comments on the document. I think I have a mail where Carlos and the author says that they are prepared to work jointly to resolve the issues. Is that correct?
Yes.
Okay. So I think that should be the starting point for this discussion.
Yeah, absolutely. So I think probably a more precise way of saying that is I was asked to do a review for the RTG directorate. Part of that uncover a bunch of issues. I would love the working group to come to terms with the issues. This is not a Carlos conversation. It's not like Carlos has issues. I'm just highlighting a few deficiencies that I see on the existing text, but I have no saying in anything other than doing a review for the directorate for the AD. Make sense?
Yep. Good.
Super. So what am I doing here today in front of you? Laura sent an email saying, look, we have this document. It's been through 3 unsuccessful last calls.
Carlos,
yes.
Strictly that I have no problem with you disclosing it, but that mail was not sent to the working group, but to a smaller group. So what Carlos says is correct, and I stand for it, but it hasn't been sent to the working group.
I did not send the email to the working group. I'm just explaining what I'm doing here.
Yeah. Okay,
right?
That's fine.
So he says there's current issues. Let's dedicate time on the meeting to talk about them. And we're going to allocate whichever amount of time to discuss that and I need you to present. And the main reason for me to sign here to including this is because I was requested to present. So the background on the document, deep diving into the technical issues now. First working group last call. I had not actually even read the document, but like Loa said, IPR blocking unsuccessful. On the second working group last call, I actually is when I first a first set of comments, and that was also an unsuccessful last call. The result of that was removing a whole section on segment routing from the document, which is like half of the document, I think. And that was because it was actually using label instead of FEX to refer to a return path. On the third working group last call, another review, another set of documents, another set of comments. The net result of that and the bump up in version after that is because the authors decided to allow multiple sub-TLVs, which was one of the initial very early comments when we look at this. Without allowing multiple sub-TLVs, we don't have the necessary degrees of freedom to actually direct the return path through things like a tunnel or through things like a nested set of LSPs. And right now, the last one is a routing directorate review, which again, link posted there. And what I want to talk about right now are the specifics of the technical issues, right? The net summary of that, from my experience, from my view, is that the document is underspecified. There's not enough to actually go down and sit down and implement an interval specification from it. So the issues. The first one is pseudo-technical perhaps, but it's about the motivation that is actually listed on the document. The document talks about the main motivation being the return path needs to follow the exact same path that the forward direction of the LSP is taken. And it goes into text like this. This is verbatim from the document. A failure detection by the ingress node on the reverse path cannot be interpreted as bidirectional failure unambiguously and trigger switchover, blah, blah, blah. To address this scenario, we're gonna allow the specification of a particular return path. However, that does not solve the problem. I mean, you can still not unambiguously interpret a bidirectional failure. And in fact, there's reasons why we traffic engineer traffic to not take the shortest path. Various reasons. Here's extrapolated example. But really, if we want to have a forward path in red, which is going A, B, C, D, E, F, and the shortest path on that network is G to A, it's probably more likely that we're going to have a better chance of having a quality return path on the shortest path, as opposed to trying to back engineer all the way exactly. Part of the point is that even if I use the same nodes, or even if I use the same interfaces, there's no guarantee that the misprogramming is happening on the return path that is chosen, as opposed to a different one. There's no, I'm not, passing opinion on whether this is useful or not. I personally think it has some applicability potentially. I don't think the motivation is, well defined in the document.
Is that strict source routing? Is that strict source routing?
Which one? Which one is?
A to G.
The red one.
Yeah.
It could or it could not.
If it's not, then ECMP and the ECMP selection means that it's impossible to guarantee what the path is in either direction.
And I agree. I agree. That's part of the reason why the motivation as laid out in the document is bogus, right? Even without going to, even if you specify interface by interface strictly, it's not exactly. And if you don't, then you still have a lot of other issues. Now, going more, not necessarily on the motivation, on the technical things, the structure of the FEC sub-TLBs. This is text that is fairly confusing because it doesn't really specify what to do. It really says we're going to include the number of sub-TLBs. None, one or more may be included, and that's how the return path specified. If none are found, then you revert to a default, which is over IP. But that doesn't really explain what if some are found and what can you use a nil FEC is allowed on the document. What do you do with a path that has a nil FEC as a specification? What if you actually have the first two sub-TLVs understood but not the third one? What if some are found? What if the LSP that you specify on the return path actually goes in a completely different direction? Right? All of those things are just not contemplated.
Sorry, Carlos, can I take you back? Why is there a problem with the thing we discussed just now? Because what you're going to do is you may forcefully detect a failure, which is a fail-safe thing to do, and probably what people would prefer. So I don't understand why there's actually a problem if you declare a failure due to a failure in either the forward or the reverse path, even if it's different. So presumably you're running it the other way around as well.
Let me paraphrase the question. Are you saying why do we need this solution?
Yeah, I'm asking why we care whether we get a false positive detection, because it's at least failing safe.
That is more of a question for the authors. I think it's probably important to.
Okay.
I think it's probably important to have the ability to select multiple paths to actually correlate, but there's nothing that you can really say unambiguously.
Indeed. I've just won. Okay, I'll wait.
This is, one of the other questions that I raised a while ago, which is confusing. The document says, if you don't understand the sub-TLVs, go to a default path, which is over IP. But when I go to RFC 5884, there's no default. There's no default path. There's no default via IP. The text from 5884 is copied there. And by the way, all of this is on the mailing list already, right? So I'm repeating, but it basically says you can go over IP or you can go over an LSP. And there's a uppercase may for both cases, and there's an or in between the two paragraphs. The word default doesn't appear on the document. One of the reasons why this is a little bit more of a problem that is a little bit more complex than the oversimplified solution that is presented is the following. This is mimicking what was done in RFC 7110 for LSP ping. And that is fairly straightforward in the sense that you have a command response protocol in which the protocol itself carries the instruction of how to return. So an LSP echo packet is essentially saying, send me the reply right now to this packet using this path, right? And there's, complexity in doing that. However, BFD is a different monster in here because of a couple of reasons. The first one is because there's persistency. This is a protocol that is not request reply. It's bootstrap, configure, and it runs, ideally forever, if it doesn't detect a failure. So you have to do with the persistency elements associated with changes in topology and how that state gets maintained on the BFD endpoints, right? So, questions like, if I specify a return path that is not available right now, shall I save that and switch over whenever it becomes available? Or if there is a return path right now and it goes down, right? Let's not assume topological invariability. Things change. That's the whole purpose of having BFD. What happens if I am actually on a return path and then that FEC goes down? or that LSP goes down? There's no default to go back to. So that is another area that is underspecified, in my opinion. There's still, after a few iterations, a number of issues with, I don't think I fully understand this. So for example, there's a return code that says failed to establish a BFD session. And right after that, it says the egress may establish the BFD session. So you're essentially receiving a response code that says, I failed to establish the session. And then the protocol says you may establish it, right? So there is self-contradicting. In terms of state, does this impose, and this is, a question for Jeff perhaps, does this potentially impose additional state considerations on BFD? Should the endpoint have to somehow have a new variable-like way of saving the return path, or not?
So I think this is operationally useful and interesting, but I don't think it is operationally required. The BFD RFC requires knowing whether the session is up or not. You get that state out of the behavior.
Thank you. Switching to a different return path is similar to what I was talking about. If there is a need to switch to a different path, how that exactly happens? There is in 5884 a provision for, if I remember correctly, optionally send LSP ping messages after the bootstrap, so not for bootstrapping, and Jeff is saying no with the head, but even if there is, I'm pretty sure there's no requirement for it. And when you take that down to practice, I'm not aware of any implementation that actually does that. And there may be, but I don't know them.
Yeah, what is actually in 5884 is strictly about how to bootstrap a new session. So the RFC is silent about how you'd actually provide changes to the session. And I think the most substantive BFD comment on this is if it is desired for these BFD sessions to be able to not only be bootstrapped with a fixed return path, but be able to update them. This is an update to 5884 procedures rather than strictly a application.
Thank you. And that was the last question. Does that update the procedures in 5884 if we want to have updates to the BFD session state while it's running? And the last, I think, and before that, Stuart.
Sorry, could you explain, why do you want to sort of modify an in-flight BFD session as opposed to starting a new one up, which, after all, you're only trying to find out whether the other end is there. So have two sessions and kill one of them when it's not fit for purpose.
So I'm not going to speak to the motivation of the authors.
Yes.
The general impression I have of this document is we're using BFD. BFD is bidirectional.
Yep.
The authors are really trying to do a unidirectional test with the bidirectional technology. The consequence of this is, a failure in the return path will falsely flag that the forward path is the problem. The technology that's trying to be specified here is an attempt to get the return LSP as closely co-routed to the sending path as possible to try to reduce the problem space.
Okay.
All the comments that have been made thus far are all good reasons why this does not always work.
So didn't the BFD version 1.0 have a unidirectional mode of operation?
No, it does not. It's always been bidirectional.
Thank you. And the last piece of technical comment on the review of the document is 5884 has some particular requirements in terms of the UDP port usage. So when you send something over IP, you use a different port than if you send it over an LSP. If we're talking about a BFD session that can change the return path from an LSP to send it over IP, there's also a change of UDP port, and the implications of that are also not explained. Thank you. Any additional questions?
Any question for Carlos? So, Greg.
Okay, so yes, I think that's what Stuart and Jeff pointed out is that we do try, with BFD over Mpls LSP, we're monitoring unidirectional construct with a bidirectional instrument. And as you see here, so if we're monitoring LSP A to B, then failure on reverse path will be interpreted by A as a failure of LSP being monitored. And if we have a protection switchover associated with it, it will trigger unnecessary switchover. The purpose of this proposal is not only to make it co-routed, but it's possible that if we deem their network that used for reverse path as unreliable, unstable, or less stable than other path, we can direct the reverse path over the more stable network. Okay, so it's not only intention of this proposal to create a co-routed BFD sessions, but as instrument to control reverse path and based on observations of operator to make it more stable, more reliable, and more deterministic in detecting the failure. That's the real intention. And yes, of course, in some cases, it might come to creating a co-routed BFD session. So the proposed mechanism is, here this ultimate co-routed, but that's not the only goal of this proposal. As Carlos characterized, yes, we propose to create a new BFD reverse path TLV to be used in conjunction with a BFD discriminator TLV in LSP ping to identify BFD session to which it's applicable, and then in the BFD reverse path TLV to have sub TLVs that describe the return path. To some comments. To the comment of IP return path. RFC 5884 says that the return path over the LSP may be possible if this is bidirectional LSP. So I'm not sure really about how many bidirectional LSPs we do have. As far as I know, only in Mpls TP. But Mpls TP does not use IP encapsulation at all. What else? Well, the document bit, we have very good discussion about procedure of using LSP ping, and I appreciate the Carlos and Jeff clarifying that the concern they have is that the mechanism of using BFD reverse path TLV in conjunction with a BFD discriminator and the changes, so basically when to use and how to use that, yes, it was implied in the document, there need to be clarification. And we agree that there need to be a clear statement that explains what is expected from LSR that supports this mechanism, how to process LSP ping with the same BFD discriminator and BFD reverse path TLV. So basically that they must be prepared to receive repeated LSP ping with the same BFD discriminator if BFD reverse path TLV is present. And we are ready to make this update and along other updates that working group will suggest.
Carlos Pignataro, Cisco. Greg, in the interest of correctness, what you just said is incorrect. You just said that 5884 says that you can use an LSP return path if they're corroded. I think that's what you said.
No, if it's bidirectional LSP.
If it is bidirectional LSP, thank you. That is incorrect. That is not what 5884 says. 5884, and I brought this just to be very explicit. It says, I copied it on my slide, but it says, or the BFD control packet sent by the egress LSR to the ingress LSR may be encapsulated in an Mpls tag. Full period. Then it says, this may be the case if the effect for which the fault detection is being performed corresponds to a bidirectional LSP or an Mpls pseudo-wire. This may also be the case when there is a return LSP from the egress LSR to the ingress LSR. Right? So basically says, you can do it as long as you have an LSP back.
Well, we are providing the mechanism to make it deterministic.
Okay, any other questions? So, Carlos, based on your review and the responses you have, do you think there is a possibility to actually converge on a viable draft in the kind of near future?
Carlos Pignataro. Like I said before, Loa, it's not up to me. It's up to the working group. That's the working group care. Is there support? Do they? The comments from the directorate that I made are as much for you as for the authors as for the list. On the line-by-line response that I saw, half of the things are unanswered and the other half are either didn't understood the comment or there's some additional disconnect. I don't know how else to answer the question.
Okay. Jeff, but you...
Jeff, I have 3 comments, and a lot of these reiterate some of the things Carlos had put in the slides. Problem number 1 is whether the MPLS working group thinks this is a useful problem to solve. Obviously, this is something you all have to do amongst yourselves. Problem number 2, there's technical issues within the document themselves in terms of how this is actually, addressed. The feedback from Carlos and the other people can help the document be better if the first one is the group says yes. If not, why would you spend time? If you want to take it to the independent submission track, that's one potential. But if you're trying to do this, the MPLS group, answer that first question. The third point is that minimally, with what you're looking to do, it would imply 5884 procedural changes. So even if you get the things resolved on that second piece, we're probably going back to BFD to get a 5884 update. So there are 3 things that have increasing levels of specificity. My suggestion is to tackle them in that order.
Okay, thank you. Okay, so thank you, everyone. I think the working group chairs have to go back and think and kind of formulate a question to the working group how we want to proceed on this. Okay. Mac, you're up next.
Okay. Hello. This presentation is about an update to the RSP pin for lab interfaces. Okay, here's a history about this draft. There are a version individual draft submitted in 2014, and it was experienced several iterations before it was adopted as a working group draft. And there's not of known understanding issue and comments addressed. After that, the draft has adopted as a working draft in the same year. And the draft, after adopted as a working group draft, it has been there for over 2 years. And this year, as requested by the working group chairs, I'm joined to try to move this work forward. Okay, here's a recall of this draft. So this draft is motivated by an issue that is encountered in live work, and it is required that to validate whether an RSP traversed over a specific member link of a lab, hence to isolate where is a failure point. And the solution is quite simple, quite straightforward. First step, the two TRVs is used to discover all member link of a lag and relevant informations. And then we can use the relevant informations to validate whether an RSP is traversed over each or over a specific member link by using the DDMF TRV. So yeah, just as I said, there's no substantial update since it was adopted, and the changes made to the draft is mainly editorial changes and some update to the references. So yeah, we really appreciate more working group reviews on the draft. If there are any comments on the issue, and we will resolve it. And for me, for the authors, we believe that the draft maybe is stable and is ready for working group last call. That's all.
Okay, can I ask, this is a draft that is about 3.5 years old, something like that, as a working group draft. How many has actually read this draft? We have a few hands, 4, 5, 6 people. So I agree with Mac. We appreciate much more working group review on this, though we probably have to figure out how to do that. Maybe she has triggered an early review routing directorate to get comments on the list. That's probably best to do. Okay.
Okay.
Thank you.
Okay, thank you.
And now it's Harish. No, it's Stuart.
Yes.
So one thing about Stuart's presentation, I think you are going to talk about 4 different drafts.
Yes.
So procedural, we only listed 3, but we're going to discuss 4 anyway.
So again?
The agenda.
Yes.
Has only listed 3 drafts.
Oh dear.
So if anyone have an objection to that, please stand up and kind of walk out or something. We're going to talk about all 4 drafts anyway.
Most of what I'm going to talk about is status, actually. So the Mpls flow identifying draft has finished working group last call. Lower picked up some minor points when he was writing the Shepherd's report. A stale reference and a minor issue with IANA. For completeness, I've addressed the issue in the text, and I will upload it after this meeting, or for the end of the week. So that's pretty well done as far as the working group is concerned. The SFL framework went through MPLS QA, and an interesting problem was raised. I'll go through the status and then I'll come back to what that problem was. It completed the IPR poll, and it's now in working group adoption poll, so please comment. The RFC 6374 SFL draft, again, has been adopted as a working group draft. There are in section 7, there are a number of methods of making measurements, which I really would like some review from the working group on. And in particular, which ones to pursue to completion. If the answer is all of them, then we'll pursue all of them. But it would be good to have a triage review to make sure that they're all needed. And of course, feedback on anything else will be welcome. So really, it's a request for please comment on the draft and help the authors in terms of direction to steer it. SFL control. This still describes just the basic standalone control plane. It really needs to be integrated with the other MPLS control planes. I've said this several times, and much to my shame, haven't done anything. So it needs to be integrated with LDP, RSVP, TE, BGP, and the segment routing control plane. We also need to put some components in it to control it via SDN. And if anyone's interested in helping with the text, their input would be welcome. So, the issue that arose...
Can you go back just for a clarification point? When you say BGP, is it 3107 you're talking about?
Yeah, when we use... yes, right.
Okay.
So the issue that arose during review was around ECMP, and this brought to, well, certainly to my attention, and I should have spotted it earlier, a limitation in RFC 6790, which is the entropy label draft, in that the inclusion of an entropy label still allows an LSR to include other labels in the entropy calculation, although it does not prohibit the it does prohibit the use of SPLs in the calculation. So the point is that I think I had kind of naively expected in my sort of dyslexic reading of the draft over the years that when you had an EL in there, that's how you did the load balance. But there are implementations that take a more aggressive approach and load balance on that and other things as well. And this is a problem because any path subject to ECMP, the packet path may change with the inclusion or the exclusion of SFL in a way that I hadn't been expecting. So there was some discussion, and Matthew helped with this, that we made two sort of changes to the text during the review process. And the key text is that if this approach is adopting, the intervening MPLS network must not load balance on any packet field other than the entropy label. Note that this is stricter than the text in section 4.2 of RFC 6790. So that is to say, we would have to verify by one means or another that that condition was applied before it would be safe to use this to be sure that the go and return path were identical.
Carlos Pignataro, Cisco. Stuart, what do you think in practice are the chances of that happening?
What, the view knowing that all the nodes conform to this?
Mm-hmm.
Well, I guess if you were doing a new deployment, then you would know, and you would probably have to take a judgment call if you didn't know as to whether you cared or not.
I guess the question is, so let me rephrase. How important of a limitation is this to the overall document? Because I think it might be hard to actually even know, whether this is the case.
Well, presumably a router would know whether it did it, and so we could get the router to advertise what it's whether it was strictly entropy label only, or was maybe otherwise.
So in order to signal, you're saying there's an opt-in signaling which needs to fill this requirement?
Yeah, you probably have to announce that you fulfilled this in order to allow you to do that.
Thank you.
So anyway, it works if you've got routers on the path that only do entropy label. It has difficulty when you have routers that decide to use the entropy label together with a bunch of other information. And I'm not sure really whether it makes sense to have routers do both, but some of them do. We would need, this is continuing from Carlos's point, we would need LSRs to signal whether they were using ELI only or they were using other factors as well. And we would need to consider whether we need to look at the text in RLC 6790, since I'm sure there are cases where we would like EL to be the only director of the ECMP process. And I think there was certainly some discussion by Eric along those lines, Eric Rosen, during the list discussion, along the lines of why does it make sense to load balance on anything other than the EL when the EL is in there? So that's where I am with it.
Yes, I think there's one question from Meet Echo. So go ahead, George.
Yes, I just wanted to make a comment on routers reporting whether or not they do these things. At least in some older Cisco equipment, whether you do such things or not is dependent on specific line cards. And in the very, very worst case, it's dependent on both the ingress and egress line cards. So getting some things to report this could be very difficult.
But George, they would be, wouldn't those routers also be unlikely EL load balancing anyway?
Yes, and that's precisely the other comment that I wanted to make, is that Stuart said, I don't know why people would load balance on something other than the ELI, and that's because that's the only thing they know. But if the stack depth that they're operating on also includes the ELI, then the ELI may, depending on the stack depth, the ELI may or may not influence the path.
No, it's a bit more complicated. It's a horrible echo. My understanding is that there is routers that load balance ELI and other things. I'm not privileged to say who they are. So
I didn't quite understand it.
Can you hear what you said? No? Can you repeat? Oh, apparently there exist routers that add load balance on the ELI plus other labels on the stack. Sorry? In most cases. Okay, so that's probably a behavior that other people weren't expecting. Okay, hold on.
Any other questions? Thank you, George.
Thank you.
So next up is Harish.
Hi, my name is Hari Sitaram. So presenting an update to this, the O1 version of this draft. So we presented the first version of this draft last IETF. And just to give a quick recap, it basically was coupling RSOP control plane with certain aspects of segment routing MPLS forwarding plane. To quickly recap what it did, it basically allocated unique POP labels per TE link of an interface and then it utilized label stacking on the ingress. So the RSVP ingress would actually stack a set of labels, where each label's operation was to pop and forward at every transit link. We also introduced the concept of delegation of label stack imposition. We briefly alluded to the fact of how one could automatically delegate label stacks, but we didn't have time to add more text to it. So this update actually adds a lot of text about delegation. We get into details of automatic delegation and explicit delegation. We also have a section separately on constructing label stacks, how a transit could construct label stacks, how ingress could construct label stacks, what it could use. We have new co-author, Tarak, and we also have George Hollow. Both of them have contributed to the draft, and based on the feedback, they're now authors. So with the delegation of label stack imposition, so the idea is to manage the stack imposition depth of the ingress. So platforms may have limitations of how many labels it could push. If the platform can push up all the labels that can carry the packet all the way to the egress, then much of what we're talking about today isn't as relevant because, well, you can push all the labels, so might as well push them. In the event that you are unable to push, we have two different approaches. One is called automatic delegation, and the other one is explicit delegation. So with automatic delegation, you actually allow the transit routers to actually automatically select themselves as delegation hops. With explicit delegation, the ingress or any path compute engine can actually specifically dictate certain transit hops to be delegation hops. So take that example on the diagram. So D and G are like delegation hops in the say. So A, for instance, let's assume for a moment that it can push only 3 labels, can actually push a packet with 200, 300, and 350. Packet gets to D, D can push another 3 labels. Packet gets to G, G can push another 3 labels. Packet can get to J. So the labels at D and G, which are marked red, are actually what are known as delegation labels. So D and G allocate these labels for the LSP. So here, from a signaling extension point of view, the RRO label subobject that we have, we have taken a bit out of it and asking for a delegation label bit. And we also have a bit allocated in the attributes flag TLV, that if it can be carried either in the hop attributes or it can be carried in the LSP attributes. So if you were to carry it in the LSP attributes, it would be automatic delegation. So the ingress is actually requesting automatic delegation throughout the LSP. If you were to carry it in the hop attributes, the ingress is basically saying, I pick D and G, and I am going to specifically, it's a per hop attribute. So I'm specifically asking D and G to become delegation hops, right? So two different flavors on how you do delegation, automatic and explicit. With respect to, now that we have two different models of delegation, you could actually stack the labels in different ways. So this basically is the slide talks about stacking only up to reaching a delegation hop. So the ingress only wants to reach up to the first delegation hop. Any transit delegation hop only wants to reach up to the next delegation hop. So in this example, you have a pop and forward tunnel from A to J. Let's assume the delegation hops are D and G. Now at the ingress and at all the delegation hops, the label stack includes the next delegation label. So if you look at the stack, the red labels from A, it only reaches up to D, and D in fact takes the packet up to G, and G takes the packet up to J. So this is one way of stacking. And we have another way of stacking where the ingress can actually stack the packet all the way to the egress. In this case, the ingress actually includes all the delegation labels in its own label stacks. And the transit does not include any delegation label in its label stack. So if you take the diagram, A actually, in this example, the difference between the previous one, if you look at A, it only has 350, 650 is at D. Here, 350 and 650 are at A. And at D, actually, 650 is already in the packet. That's arriving from C. So this allows the ingress to actually stack the packet all the way to the egress. Of course, now that you have two different ways of stacking the labels, you actually have to have a way to let the transits know, please don't stack the next delegation label in the stack. So by default, if we use the LSP attributes, we do automatic delegation. If you do automatic delegation, the transit router is by default going to take this approach. So it's the transit routers are going to, each router only tries to reach up to its next delegation hub. If we want the ingress to actually do the complete stacking, then we can include another bit in the label, LSP attributes bit, where the ingress can actually signal telling the transits, please don't include the next label in the delegate. Please don't include the next delegation label in your stack because I'm going to include all of them in the ingress. So there are two different ways of stacking it. So so how does in automatic delegation, how did the hops first of all pick themselves up? Like how did they auto delegate themselves? So in this example, we can still assume from the earlier examples to stay consistent, D and G are delegation hops. We introduce a per hop attribute. Basically, we've introduced in the hop attributes object a per hop attribute. It's signaled in the path message. Ingress basically populates it with the maximum labels that it can actually push, how much ever it can push. And each successive hop actually decrements it by 1, or it also looks at its own limitations. It could look at its own outbound limitation, it could look at its own inbound limitations, and then it can decide to not decrement it by 1, but it can actually set it to something else. And so if a node is reached where the incoming ETLD is actually 1, that node actually selects itself as a delegation hop. Once it selects itself as a delegation hop, it again follows what the ingress used to do. It sets the ETLD out to the maximum value going out of the box that it can push and pushes the packet out. By the time the packet reaches the egress, all delegation hops have been picked already. So so that's how the delegation, the ETLD mechanism is used in the signaling to actually make this work for automatic delegation, specifically for automatic delegation. So yeah, I mean, next steps, we actually have to add some text for node protection. We have a bunch of bits that we are asking for, specifically 6 bits, I think, in different attributes. So request early allocation of IANA code points feasible. And at this time, based on the comments that we received last time and the response we saw, we request working group adoption. Yeah. So.
Hi. Probably stupid question. RCPT doesn't stack labels; it swaps labels per hop. Where does it come from? Maybe I'm missing something.
Oh, what? Oh.
Why are you going to stack labels in RCPT case?
Oh, the first time when we presented is basically you can overcome platform limitations of how many labels can be there in the forwarding planes. For example, one example could be a platform could have a limited fib size. So RSVP could potentially still scale way past, not limited by the number of labels that are needed in the stack. So in this example, for instance, the forwarding plane actually is more decoupled from the control plane. The forwarding plane only has as many labels as the number of interfaces or neighbors on that box. As opposed to if you had, say, 30,000 LSPs across a node, you would need 30,000 labels today. So with this, you would only need number of labels as per the number of interfaces or neighbors on that box. And so you could, one other way is you can more decouple it from the fib size capabilities of any box.
The real use case on today's hardware?
That's not the primary motivation though. That's one of the motivations. Others are basically you can cut the amount of fib state you actually need. All the chatter that occurs between a control plane to data plane. So,
thank you.
Sure.
Can you get your last slide?
Last slide.
Okay. Deborah, early allocation is only for working group documents. All right. I can't do it on an individual.
Deborah, yeah, it has to be a working group document because one of the rules is it should be somewhat stable, right?
Yeah.
We shouldn't just be requesting these and then with a high probability of completion. as
It's
Stuart
actually
pointed out.
a stable working group document. Let's say,
It should
okay.
be, yes.
Yeah, so what my conclusion here is that early allocation is a little bit premature in this case. We have to wait until we have an adopted working group document and actually are fairly convinced that the document is stable enough to allocate code points for. So I appreciate that you bring it up.
Pawan, speaking as a co-author, so that's the reason why we're asking for adoption, because we would like to see early allocation of code points.
So I don't know if I got you correctly. Yeah, but you can't ask for early allocation for an individual draft.
But this next point is request working group adoption, which is.
Yeah, I understand. The point, though, is that we have the high probability hurdles to get over also. So we are not going to do it in the order we have it on the slides. We're going to do. You're going to update the draft. We're going to go through the process for working group adoption and see where that leads. And if we have a stable working group document, then we can do early allocation.
Fair enough.
That's the point I wanted to make. Okay, you done?
Yep.
So, thank you. So now we should have had Cameron talking about MLDP and LDP Yang models. Cameron is one of those that can't travel at the moment. I don't really know why. So, Su Feng, you have the last 10 minutes to present the work going on LDP and MLDP Yang.
I'm Xifeng Liu, giving a brief update to the LDP Yang and MLDP Yang model. So since last IETF session, we had a few discussion meetings, but we have not got chance to submit the updated draft. So here's the discussion we had. We decided to do a few changes. We decided among those authors and contributors, we want to simplify the policies specified in the model. So here we will move the currently existing in the base model, the explicit non-control policy, move that into extended, and also we'll remove a few combinations about the policies. So we'll take out the per AF policy global level, and we keep the per AF per address family policies, but remove the all address families from the global and from the per peer global. And we also have sent this document to young doctors for review, and we haven't got the review result back. They're working on that. We got a few questions, so we're going to answer those questions and work with the young doctors, complete the review and address any review comments. So here are the pending items. So we need to complete the default values and then complete the young doctors review to address any comments. Then we need to update the model to be NMDA compliant. We may need to use the state model also. The next step, we'll publish a new version of the document. After that, once we have addressed all the issues, we'll ask for the last call. Another document here will be the MLDP. So again, we haven't got a chance to update the document, but we also had a few discussions. We decided to change the configured RSP model section, and also we're going to update the notification. So here is the change we have already decided to do. So we'll here we can see we'll expand the we'll expand the configure the leaf RSPs. We used to be able to only handle one particular OPIC type, which is a RSP. Now we'll add other OPIC types like transit and the binder. So actually this change will also take care of the second bullet here. So make the RSP configuration and the state model consistent, because on the state section, we already have those different OPIC types handled. And then we also plan to change the notification. Again, here we expanded the OPIC types, not only including previous existing RSP ID, but also covers the transit and the binder. Some open items include default value and updating to the NMDA style. And then we'll publish a new version to address those issues, and we then do the doctor review, and then we can ask for last call. So these are the items we have.
Any questions? Okay, so a comment on the Yang doctor review. We had our wire crossed. So we requested Yang doctor review a little bit late. We got, or the Yang doctor sent us a mail, and we actually failed to recognize that what that mail was, so we didn't respond. That's, I don't know. I think people were too busy doing too many things, really.
I think that came, the question came is late, so probably a week before the deadline. So we didn't have the meeting after that, so we didn't have a chance to discuss.
But we are on track now, and we will resolve those issues as soon as we can.
Mm-hmm.
Any other questions? Okay, so thank you.
All right, thank you.
Okay, I think it's too late. We don't start a new presentation now. We take everything on Friday. Who hasn't signed the blue sheets? Anyone who hasn't signed the blue sheets comes up here and sign the blue sheets. Other than that, see you on Friday at 10:30. The same room is on the agenda. Time is different. 10:30. See you. Bye.
And the second blue sheet is still missing, so where is it? Who has the second one?
Someone on the seat in the blue sheet.
Yes, one. No, I will check.
Hold on. Hold on. Hold on. Can you look at the last row on shares if there is a blue sheet laying over there?